All right, my name is Jason. I am the VP of Trust and Security at a company called BugCrowd. At BugCrowd, we host, manage crowdsourced security solutions, in particular bug bounty and responsible disclosure programs. But I'm also a tester, and I've been a pen tester my whole life, and I continue to be a bug hunter. And this presentation basically goes over a whole bunch of bug hunter tips and tricks, as well as vulnerability classes that are pertinent in today's bug hunter type of life cycle. Any of you hunt bugs on BugCrowd or any vulnerability disclosure program or anything like that? HackerOne, Synac? A couple of you? Yeah? Hopefully, this will have some good stuff in it. This is kind of a year of parse knowledge, basically. So I did one of these at Defcon 23. What I did is I took all of the top hunters back then. They didn't have a lot of blogs. There was not a lot of information. And we took all of their methods from their blogs and disclosures and stuff like that and tried to distill them back to how they test and how they found big quality bugs. And then what automation and tooling was good in those sections. And so that kind of turned into this talk that I gave at DEF CON. And so the idea is I redo this every year with the new pertinent bugs that basically high quality, high impact bug bounty hunters find on programs to help the rest of us get up there. So the first version of the bug hunters methodology had things like discovery and mapping and parameters off an attack, and this one will have those things too. It's set for revitalized with new data, new tools, new fuzz strings, filter evasion techniques, stuff like that. The vulnerability classes I covered in the last presentations were things like SQL injection, cross-site scripting, file uploads, CSRF, and privilege. Some of those are going to be the same, and some of them have changed in the 2 years since I did this talk at DEF CON, so we're going to talk about some of those. So in this year's, we're going to do more discovery, a lot of discovery, and I'll talk about why that is. Advents in cross-site scripting, a new vulnerability-ish class called server-side template injection, server-side request forgery, some advents in code scanning for code injection, command injections, and just some general advents in web fuzzing, and then infrastructure and configuration. So when you're doing bug hunting or you're getting into ethical hacking or anything like that, there are some books that you really need to put on your bookshelf. One is the Web Application Hacker's Handbook, and this is considered kind of the Bible for the Web Application Hacker Handbook. It really breaks down the methodology, the syntax, all of the attack techniques, and it's written by the authors of a tool that we all use in web application hacking called Burp, Burp Suite Proxy. After that, shortly following that is the OWASP testing guide at the bottom, and that's referenced by OWASP. It has basically a list of all types of vulnerabilities and how to check for those. Now, there have been a couple books I really recommend adding to your kind of bookshelf for this, and one is Web Hacking 101 by Peter Jaworski. This book is actually really awesome. It goes through a whole bunch of disclosures of his bugs and other people's bugs on the HackerOne platform because they have disclosure. Breaking into Security by Andy Gill, and Modern Web Penetration Testing, which is a PAC published book. So these three are kind of add-ons from the last presentation that you should have in your bookshelf if you're going to do modern web application assessment. So the first section of this presentation is all about discovery. And the idea here is that if you look at the cross-section of our researchers, you can think of them or bug bounty hunters, you can think of them in a triangle, right? And at the top, we have the heavy hitters, the guys that get paid 10K a bug very regularly. They do this for full time, right? They have a certain set of skills. If you take their submissions and reverse them out down into what vulnerability classes they're finding. So we wanted to find out, well, how are they and what classes of bugs are they finding at that top of that pyramid so we can get the middle of the pack up there, right? That's what we want as BugCrowd. So one of the things that we found is really good hunters are really good at finding attack surface that was unknown, which I call discovery. So what this is finding websites that your development crew stood up for 2 days and never took down offline. Things like marketing sites that marketing stood up, never took offline. Internal systems that have been left out there. I think there's a term called like shadow IT, basically. These are all those systems that everybody has forgotten, but are still connected to your cloud infrastructure or even your real infrastructure. So this is a methodology that is parsed from myself and a whole bunch of other people. Discovery is actually one of my specialty areas. And it goes through how to find lost and orphaned sites because they are often less secured than the main.com, and you can often find really juicy vulnerabilities for these sites. So in the last version, we talked about a couple of things, which was subdomain scraping. We talked about a couple of tools, and we're going to talk about advents in these toolings, and then also some of the other stuff that goes along with them. So when you have this idea of finding domains that are left out on the internet that no one remembers, or that you just kind of want to find all of the application space for one of these companies, the first thing you want to do is called subdomain scraping. And subdomain scraping basically goes out to all these sources on the internet, like certificate repositories. It goes out to search engines like Google and Bing and Baidu, and basically it searches for your main domain here, like Tesla. Tesla has an open bug bounty, so they let us show all the tools running against their domain here. And you can see here that this tool will look in Bing, Yahoo, Google, Ask, Netcraft, DNS Dumpster, VirusTotal, SSL certificate repositories, and passive DNS, the website. And it will look for anything that has tesla.com associated to it and any of those sources, and it will parse them out and give you a list of everything it finds. So this is a tool called Sublister that combines all of those into one tool. It's made by a hunter called Abulea, I think that's right, Abulea, something like that. Excuse me if I butcher names. And it hasn't been updated in a little while. If you look at this repository for Sublister, there's actually a fork maintained by another author that actually has a few more parsing methods other than Bing, Baidu, Ask, and all the ones that are listed here. So if you just go to the GitHub and go at the forks, look at the most updated one, and that guy actually has some checks here to see where these redirect by IP, and then also if they're associated to any places where you could possibly hijack the subdomain, which is a vulnerability we're going to talk at the end of the presentation about, which is hijacking subdomains. So this is search engine basically scraping. And so Sublister is one of the main tools to use here for finding orphaned sites. So in subdomain scraping, this is one method of discovery, right? There's lots of methods. You have 2 or 3 tools that are really pertinent in this area. So you have Sublister on the right here. And then you have another tool set called ReconNG made by Tim Tomes. And ReconNG is actually a whole OSINT framework to do discovery on people, places, domains. It can do OSINT on anywhere. And then I wrote a tool that wraps around ReconNG called enumall with this guy, Leaf, right here. He did most of the coding. I just managed it. And and it does these 3 on the left. SSLtools.com, it parses from their API. HackerTarget.com, it pulls data from their API, and Shodan. There are some optional modules at the bottom. ZoomEye, ThreatCrowd, just a generic zone transfer, the RiskIQ API if you own an API key for that, and Census.io, which if you own an API key for that, you can pull down with ReconNG. So there are some that are specific to each tool, and a lot of people end up using both of them. Oh, and then both do the middle column. So luckily, people realized that you didn't want to have 2 tools in one, so they made a Docker container called BruteSubs, which basically wraps these 2 tools and one other one called AltDNS, which we're going to mention soon, into one Docker container that runs from one command. Because all you want to do is really search one domain for one command, parse all of these different input sources, and get a list of stuff that you might want to hack on for bug bounties. So this is that Docker container, and it's pretty simple. Just Docker compose with your up, and then you have to set a config file with your target, and then it runs all these tools on your target. So here you can see it's going through and using multiple tools, and it'll concatenate the results. So that's called BruteSubs. So that's subdomain scraping. That's pulling from all these sources on the internet to find stuff that's either been cached by a search engine, it's been somehow leaked via certificate, something like that. There's another couple of ways to do this which are pretty cool as well. So anybody in here use Cloudflare? Some of you, right? So when you start up Cloudflare for domain, they ask you for your domain, and then they do like this magic wizard that shows you all of your sites, right? They have this giant database at Cloudflare already mapped out of the internet. They know where your domains are, what your namespace is, and what IPs are associated to those domains, and they're ready to deliver you Cloudflare on all of those. Well, as bug hunters, we created a script to go through that login cycle and parse their data set and pull it back into the stuff we should attack. So this is Cloudflare enum. So here's Disney. I didn't run this, sorry, if you work at Disney. This is from the man page, sorry. And so you give it your credentials for Cloudflare. You just create a fake account. And then you give it your email, your credentials, and then it tells you what the Cloudflare magic database comes back with. This one actually gives you some pretty good information. There's another project called census.io some of you might use, and there's a script to parse that as well. These haven't been integrated into an automated tool yet, but they will be really shortly. They'll actually be part of the new fork of Sublister, which I'm helping with. So that's sub-scraping, getting subdomains from a whole bunch of sources that are out on the internet and trying to list them out so you can attack them and find the juicy ones where the good vulnerabilities are. There's also this idea of subdomain brute forcing, right? So you have tesla.com and then you just try to resolve admin.tesla.com. And if that doesn't work, you try to resolve customer service tesla.com, right? And this is brute force. This is brute forcing the subdomain part of the domain. There's multiple tools that have existed for this for a long time, right? Some of you might have heard of Fierce, which is an older but very common one taught in pen testing courses. Really, there's a new class of this tool that have come out in the last couple of years that dramatically increase the efficiency of this type of finding, basically. So there's two tools. One is mass DNS, and one is GoBuster. And both of these are brute force tools. With the syntax listed here. And so I did a case study of how long it took to run through a 1,136,964 line subdomain brute force list, which I made. I took every tool that I'd ever seen do subdomain brute forcing, I catted it and uniqued it into one file. And I'm talking about stuff that's from like 15 years ago. I put it all into one file and I ran it through some of these tools. So you can see the runtime subbrute, which is a common one taught in pen testing classes, just errored out with this size of a dictionary. Just couldn't do it. GoBuster took about 21 minutes. Mass DNS, because it's a distributed program written in C and it uses multiple DNS resolvers to try to resolve the DNS, uses up to 150, took 1 minute and 24 seconds to run that whole file. Now, there are false positives in this tool. So depending on the resolvers that are returning stuff, sometimes they'll just return yes, that this thing resolved for a lot of stuff that didn't resolve. So you'll get false positives. But the thing you'll notice about the false positives in the output of mass DNS is that they're pretty easy to spot because they all return like these generic like CNAME errors in the tool. And so you'll know right away that they're false positives and you can just grep them out. So mass DNS and as a backup, GoBuster are the tools that you should probably use for subdomain brute forcing. And this is the hardware I used for that case study at the bottom. And you'll have to excuse me, I've been sick like all week, so I'm trying to, persevere. Okay, so we talked about subdomain brute forcing. This is the combination of basically all of those word lists for the brute forcing. I just called it all.txt. It's a gist at this address. You can grab it. I use it in my pen testing all the time. This is like every program that's ever done DNS brute forcing on the right here. Just put those all into one list, uniqued it, and so now you have that for your own usage. Mass DNS is at Blechschmidt. That's where you can pull down mass DNS to do some of this. And so those are two advents in kind of subdomain brute forcing in that part of discovery. In addition, when you have a bug bounty that is open scope enough, like Tesla's is basically any system that you can verify that Tesla owned is included in their bug bounty. You can check for acquisitions for some of these programs, as well as in Facebook and Google, but they have a wait period. They have I think it's maybe 3 months after they acquire a company. You might need to wait until you submit it to their bug bounty. And I'm assuming that's how long it takes them to migrate IT over to Facebook or Google. I can't remember which one the wait period is on. But once you do that, you want to have mapped out that, hey, look, Tesla acquired Grumman Engineering, Solar City, and Riviera Tool over the course of their lifetime. Are all those assets that might be related to a company that Tesla now owns, have they been tested? Have they been hacked? Do they have bounty-related vulnerabilities on them? Maybe, maybe not. So Crunchbase is the place to go for this. Crunchbase has a lot of financial data related to acquisitions and stuff like that. So you can go to Crunchbase and pull down related acquisitions. So then after you have all of these hosts via subdomain scraping, brute forcing, maybe some acquisitions, And when you find the acquired companies and their domains, you put them back through the subdomain scraping and brute forcing. You finally have this large list of targets maybe you want to go after. Now you have to port scan them, because to not port scan them would be unfruitful. What happens a lot of times is these things have remote administration protocols open on them. They have web servers running on high ports that people don't even think to look out for. So, in the traditional kind of web testy method, you would use Nmap to scan 65,000 hosts with Nmap. This is a large targets ASN, or maybe large discovery from the methods we just mentioned before. That just takes forever. It'll just like put you to sleep. If you want to test all ports, or even just the default Nmap ports list for this, you might as well wait a month for that type of scanner, maybe a week, maybe a week. So MassScan is the solution to this problem, distributed, written in C. Actually not distributed, written in C, way faster, higher error tolerance on the scanning. So this is the syntax for running MassScan against 65,000 hosts with the default Nmap port range. You'll need some serious hardware in the cloud to probably do this. So I commissioned a DigitalOcean box with plenty of memory and bandwidth. But time to run 65,000 hosts with the default Nmap port list, 11 minutes, which is not that bad for this. So pretty amazing. All right, so you have a port scan. You have a whole bunch of domains with ports on them that are open. You're ready to hack them. Now you need to know which one of these domains that you pulled down earlier are worthy of attacking first. Some of those sources that we pulled from might have been taken offline, because one of them was search engines, right? And search engines cache old information sometimes. So some of those domains might have been pulled offline. Some of the domains might exist as a DNS entry, but they might redirect to the main Tesla.com site. So how do you account for that in your recon? Well, you can use a tool like Eyewitness, which basically takes a list of everything you have, which is at this point domain names and subdomains, and appends HTTP and HTTPS, tries to resolve each one of those, and takes a screenshot of each site after all the resolving has taken place and all the redirects have taken place. Then you get a folder like this on the right, which has all of the basically pictures of what it landed on, and you can start to get a good feeling as to what you want to hack first. Obviously, if you land on something that's like an admin page or a developer console or a login, you want to check those out. If it's just the Tesla normal homepage that you're supposed to land on, probably not going to prioritize that right away. All right, so now you have domains, ports, prioritized places to test via like visual identification. Now you kind of want to do some platform identification and to see if any of their web server software or components are outdated. These will provide quick wins and bounties if those vulnerabilities associated to old versions in their server software or their third-party code is vulnerable to something. You won't have to do any work, basically. You'll see that they're running an old version of something. You'll go Google it. You'll see, okay, here's the exploit for that, and you'll exploit it, and you don't have to do any work yourself. So there's a couple of things. From the first presentation, we talked about this tool called retire.js, which will go through third-party JavaScript libraries and tell you if Node.js is out of date and has vulnerabilities associated to it. For technology mapping, to see what a site is actually running on the server side, what stack it's running, there's Wapalizer and built with. And now there's a new burp plugin called Vulners, and there's also an Nmap plugin for Vulners as well, that as you passively visit sites in burp, instead of just giving you basically the application level vulnerabilities, it'll also start parsing version numbers that show up in readmes, in the headers, everywhere, and tell you that there's vulnerabilities associated to anything behind the version they're running at. So Burp Vulner Scanner is a new tool to kind of identify some of these easy CVEs that already exist. Okay, so none of that substitutes for actually walking the app, right? Like a lot of bugs are highly contingent on knowing what your application does very intimately, especially things like insecure direct object reference or missing function level access control, those type of bugs. Very contingent on you actually using the site instead of just using all this automation. So I put the slide in here just to say, like, don't forget to get very cozy with your app and understand what it's doing. These are ways to expand your scope and to do discovery, but once you land on that site that you're going to hack, really put your effort into it. All right, so once you're on an app that you want to start hacking, one of the first things that people have done is use a tool called Dirbuster. Have any of you used Dirbuster before? It's an OWASP tool. Cool. So it is a directory brute forcer. So we have tesla.com, right? Now, in order to discover everything that might be on tesla.com, I spider it, and I see it has all these URLs and parameters, and it does certain things. But there are hidden things that it might do, hidden admin panels, hidden parameters, stuff like that that might exist on that site. So we brute force a whole list of common pages for that type of stuff. Now, traditionally, Dirbuster was the tool that you would use for this. Now there's a tool called GoBuster, which is written in Go. It's much faster. I didn't need to do like basically a comparison for this because this has just kind of been what we switched to, and I think a lot of people are aware of GoBuster already. So, but GoBuster is a tool you use for content discovery or directory brute forcing. Now, Burp has this idea too. It's called content discovery. It's available in the Pro version of Burp. Not everybody has the Pro version of Burp. If you do have the Pro version of Burp, you're counting on that the word list that they're brute forcing in the path is as good as the one that comes with GoBuster, or the ones that are out in the open source community for brute forcing these types of paths. The best one right now that exists for doing this is called Robots Disallowed. It's one of the best. It's written by Daniel Miessler, who's sitting right there. So he maintains, basically you parse like the Alexa top, like million or something? Yeah. He parsed the whole Alexa list of their robots.txt files and then sorted them by occurrence. So robots.txt meaning that developers don't want you to know or go to those pages. So that's exactly what we're going to go to. So you feed this thing to GoBuster. You feed this list to GoBuster, and you find things that developers didn't want you to go to, hopefully things that are juicy and that have vulnerabilities associated to them. So then there's the idea of like we found pages that are good that we want to attack and we want to fuzz, and that's general web hacking, is putting stuff into parameters or input fields and seeing what happens. But there's the idea that there might be hidden parameters associated to pages or functions or scripts. And so there's even a tool to brute force parameter names if you're with an API or you think there's a hidden parameter or something. It's called parameth, and it's written by a guy named Syrian Mako. He's a bug hunter. And so this will brute force parameter names. Burp, the authors of Burp Suite did a project as part of something else that they did, which mapped the top parameters that applications use, the parameter name, so ID, action, page, name. And they mapped all of these by occurrence, so you can feed these to parameth if you're fuzzing like an API or something like that. This can be either like the syntax of or script question mark equals parameter or something like that, or it could be the the REST style or whatever. You could do either, but you can brute force parameters with these type of tools. So this is the overall discovery methodology, right? Identify IPs and main TLDs, scrape, brute force, port scan, do some visual identification, identify the platform, do content discovery, and then maybe do parameter discovery. So this is most of the active stuff. There is some other stuff that you can do as part of Recon, which is like trying to investigate GitHub repositories associated to companies and map out their technology that way and find paths and even deeper parse JavaScript files that the company's hosting to pull out paths out of there. Those are new advents in kind of mapping sites, but I didn't include those in here. But they're actually in a presentation that Ben wrote for Level Up. That was like 6 months ago or 8 months ago. And he did a whole presentation on a couple of those methods, right? So, cool. So one of the topics in the last one, in the last Bug Hunters methodology, was cross-site scripting. And so we're going to talk about a few of the advents in cross-site scripting. So not really a lot of advents in cross-site scripting. Cross-site scripting remains the same, except for the addition of a quasi-new category. So, and I'm just going to draw on myself as an example here. For the longest time, I was pen testing for years, throwing in attack payloads into parameters and boxes, input boxes, that I was shooting alert payloads into, right? And I was getting cross-site scripting and I felt great. But for years, I was missing out on the fact that if I would have had a little bit more JavaScript and a little bit more experience, I could have added what's called a JavaScript hook. And then when I sent a cross-site scripting payload into a form, I might not have gotten immediate response from my page, but someone in customer service for that company might have eventually seen that attack string, and it would have popped up on their internal customer service admin portal. So this is a category of cross-site scripting called blind cross-site scripting. And there's a couple of frameworks here to manage and test for blind cross-site scripting. So one of them is called Sleepy Puppy. It's built by the Netflix team. Anybody from Netflix in here? Yeah, awesome tool. So Sleepy Puppy is awesome. There's some other ones. There's Ground Control by Yobert Amba. How do you say Yobert's last name? No, sorry. And then there's XSS Hunter, which is a framework for managing the callbacks for this. There's also some things called polyglots, which have come around, which are basically identifying cross-site scripting using one string that will execute in multiple contexts, which helps you quickly identify some versions of cross-site scripting. And there's just some other resources here. So this is the idea of blind cross-site scripting. So this is Franz. And Franz, in step 1, finds a form field for name, last name, and organization. Franz puts in a script like this. It says script source equals y.vg, which is his domain he owns. And so when anyone visits that and that script executes, it will call back to his y.vg domain, and he'll know that someone saw that. Immediately, he sends it through the tubes, and it ends up that he doesn't get an alert right away. So there's no stored cross-site scripting, there's no reflected cross-site scripting, but all is not lost for Franz. So eventually it ends up on Jamie's computer, and he works for Yahoo, and he has a customer service portal he logs into every day that reads emails or an application parses that information. And it pops up on Jamie's admin console. Then it executes a shell, a JavaScript shell, back to Franz's server, y.vg, and then Franz now has the same access as Jamie, can instrument his admin panel. This is blind cross-site scripting. So Sleepy Puppy's really good, Ground Control is really good, but the one that a lot of hunters use is actually XSS Hunter. So XSS Hunter is a framework that instruments blind cross-site scripting. It generates hooks for you. It will also email you when you get blind cross-site scripting triggers. When those customer support reps actually open the email, it will email you. It will send you reports. It has the ability to basically parse and change the payload. It does a lot of cool tricks like Beef and XSS Shell used to do when we were doing like demos of that. So XSS Hunter is kind of the framework that you would use nowadays to manage cross-site scripting attacks for blind cross-site scripting. Okay, so in the last presentation, we talked about this idea of polyglots, and you can look it up. It's from Defcon 23. We talked about 3 of the most common XSS polyglots. The idea of an XSS polyglot is that it's one long string that can execute in multiple contexts. So if you put it in a form or a parameter, wherever it lands on the page in the HTML, as long as there's not sufficient output encoding, it will alert. You don't have to fiddle with it to get it to match the context of your page. You just paste in this one string, and it should ignore all the parts that it doesn't care about and alert on the part that it does care about. So there are 4 main one of these that exist. This is one by HackVault called the Ultimate XSS Polyglot. It's not actually the one I use the most. The one I use the most is part of the old presentation by, it was invented by a guy named Ashar Javed. A lot of scanners are starting to institute polyglot payloads because they don't send as much traffic to the sites, and they don't have to worry about context in some of their scanners. So this is kind of where some of that fuzzing is going these days. If you're really into manually mapping context for cross-site scripting, there is a new resource out there called the XSS Mind Map by Jack Massa. And what this does, it's a giant mind map of cross-site scripting payloads based on context. So you can drill down if it's lands in the DOM, if it's part of Flash, if it's part of React or jQuery frameworks. If you're trying to bypass or stay under a character limit, there's basically notes or actual payloads to use against that type of context and examples. So this is one of the new resources that's really cool for cross-site scripting. Not that any of these are new, but definitely organized really well. Okay, so that's cross-site scripting. So now we're going to talk about a vulnerability called server-side template injection. So there are a number of template engines out there. I use Flask a lot for easy development projects to make CTF, stuff like that. But if you use the templating engine, there's the opportunity that there could be a remote code execution bug called server-side template injection there. Now, I'm not a templating engine expert, so I just know that this vulnerability exists. I've kind of built CTFs around it before, but I'm not like 100% expert. So identifying sites when they're using a templating engine is the same thing that we would normally do. You would use Wappalizer or built with to verify the stack on the server side and see what they're running. You would fuzz parameters, but really there's a couple of tools here. When you identify that you're using a templating engine, Marco, Dust, Jinja, any of those, Tornado. And this is the idea of a templating engine, right? So here you have an error page that's going to parse this URL, or when you get redirected to this error page, it's going to parse the URL here. And instead of providing it a parameter, or it's going to parse this page, you give it a math operator inside some mustache braces, or you ask it to read a file in the second one here. Wait, hold on. Yeah. So there's an excellent article here. I have it in the resources page that explains like actually how we're finding out which class to use for the file read here, and this is against Jinja. But most of the time when I'm fuzzing for SSTI, I use the payload on the top, right? What I want to do is usually I'll have like a page or an input parameter field of name or something like that, or whatever the parameter name is or whatever. And I'll just put in a payload like 2 times 3. And if it gives me back, if it evals the math and gives me back page 6 or it gives me back 6, I know that I'm probably good for server-side template injection. Now there is a tool called TPL map, which is very similar to SQL map, which knows each template engine and how to construct and find a class that will be able to get you an operating system shell when template injection is available. So TPL map, here I've given it a URL that's vulnerable, and it identifies the template injection in the name parameter. And then I tell it to get me the Etsy password file, and it's going to do that in a second. So they're actually giving me an operating system shell. I did --OS shell, very similar to SQL map, except for all for templating injection. And it got me the OS command shell. It goes pretty fast, sorry. So this is one of the bugs that is like a P1 bug on most systems, new class of ish bug. Server-side template injection was actually found by one of the people on the burp team, so they have a whole white paper on how this works. So what we did at BugCrowd, this is actually off a little bit on the style, sorry. It's from a different presentation, but I thought it was apt to add into this presentation. So what we did at BugCrowd was we took all of the parameters that were most often vulnerable to this class of vulnerability and ranked them by occurrence. And so what happens when you build web applications or you end up using these technologies or these frameworks, they either provide you parameters or you think of one yourself for the data you're trying to handle. And semantically, it ends up being the same parameter that's associated to a lot of the same vulnerabilities. So for server-side template injection, these are the top parameters that are vulnerable to this bug: preview, ID, view, activity, name, content, redirect, and template. Template makes a lot of sense, right? Templating engine, template. So for debugging and logic, which this slide came in from another presentation, but for applications where you want to try to fuzz for debug or logic functionality in a URL as part of a parameter, this is that list on that side, which is access, admin, dbg, debug, edit, et cetera, et cetera. So this is part of another presentation I did called Hunt. I made a tool to alert whenever burp saw these parameters to tell you to go test for certain classes of vulnerabilities. That's a whole different presentation, but I included the tables in here so that if testers really want to get intimate with these type of bugs, they know the type of places to look. So here are those resources. The original white paper for SSTI, the SSTI workshop that was done by Jerome Diu, SSTI in Flask and Jinja by Tim Tomes. Really, like, I'm not an expert on something. I'm going to try to give you the best resource that you can go learn about it. So this is kind of what I do at the end of each section. So this is where you would go. And then Pete's a good friend of mine, so I put a little bubble here to say what's up. Okay, so another vulnerability that pays out well is part of kind of the elite hunter kind of methodology is server-side request forgery. So server-side request forgery, we didn't really talk about it that much in the first version of the bug hunters methodology. We're going to talk about some resources and tooling for it. In this one, we're going to move a little fast because I'm running out of time. So the same as other places, here's the table for the most often attacked parameters for server-side request forgery. File, folder, location, style, locale, template, path, doc, display. You'll notice some of them are the same for all vulnerability classes. That's okay, I don't care about that. This is a very small handful of params to test really, or to be alerted on. So that's that list for you. The idea of SSRF is you have a function on a website that normally takes a path, HTTP usually in most cases, and it's trying to do a redirect or pull some kind of content from the value of that parameter. So you can see the value of URL here is http://google.com. Well, what if you pass just //google.com? What if you pass it without the HTTP with the protocol or the slashes? What if you pass it with just a path to something else here? Well, you can do malicious things when those functions aren't coded correctly, like use the file protocol to read etc password on the bottom, or use TFTP to internally port scan the server because they haven't disallowed that protocol handler in that parser. So there are a whole bunch of ways to do this. One of the presentations I list in the resources section is this presentation by Nicholas, and it's a whole bunch of ways to notate IP addresses or web addresses that can get past blacklists that people try to disallow this attack in, or really, whitelist any type of, pathing attack. So these are different ways that you can do that. You can bypass some WAF stuff. Really, this is the ultimate cheat sheet for SSRF. It tells you by platform or by stack or programming language, basically, which ones are vulnerable to which protocol handlers by default. So you can use this if you see a URL. Basically, my methodology is use burp. If you see anywhere in a parameter value that a URL is getting passed or a path is getting passed, start to fuzz it, find out what platform it's on, and then reference this cheat sheet, what is usually enabled by default on that technology. Try to use those protocol handlers and try to pull out bad files. These are the most common parameters for server-side request forgery. You can grab these slides offline, so I won't go through them. And these are the best resources for learning server-side request forgery. Okay, I have 10 minutes, so I'm going to blast through this. Sorry. So for just code injection or command injection, or just kind of new fuzzing ideas in the last, whatever. In the last version, talked about SQL injection. SQL injection, not super, although it's a super impactful bug, we don't see it a ton. It's not a top bug that we see a lot of testers finding nowadays. A lot of mitigations against SQL injection. But command injection, funnily enough, still exists in a lot of web applications. And then the idea of custom fuzzing as well is a thing that we see, as well as IDOR or missing function level access. So this is, IDOR is the idea where you have a numerical identifier inside of a URL, and if you increment it or decrement it, you can get somebody else's data back, right? That's an IDOR bug. So IDOR still retains its kind of king status to bug all of our bugs. IDOR gives you the highest payout. Applications are most often vulnerable to it. This is an instance of a site here that was vulnerable to an IDOR that let you pull down from an endpoint that gave you JSON data on a customer. And so basically all you did was there was a SERID parameter, and you incremented it by 1 or 2 or 3, and it would give you back someone else's data instead of your own. This happens all the time. I don't think I've seen a web application that has access mapped very well that hasn't been hit by an IDOR before. It's super prevalent. There's no real framework to fix access bugs. So they're usually pretty latent in applications. So the things that you do here to find IDORs is look for numericals in parameter values, which sounds like every site is going to have that, but you'll know when you see it's like ID equals or something like that. You'll know by the parameter if you should try to iterate it or not. If you see an email address, try to change it to a different email address. If you see a hash referencing something, try to change the hash. Create 2 accounts, and if one has a unique hash as it's referencing an account, just steal the other hash, see if you can substitute it. And a mix of some of these exists on some of these sites. These are the most common parameters associated to insecure direct object reference. Again, this is out of another presentation called Hunt that I did at Defcon. Command injection, really, that one's kind of been covered a lot, but there's a tool called Comics, very similar to SQL map and TPL map, that exploits command injection. And it has the ability also to give you reverse shells in PowerShell or Python and integrate directly into Metasploit, which is pretty cool. There is some other advents that have come out. So Burp Suites has an optional module built into it now called /powered scanner. And what it does is it doesn't actually fuzz for any singular vulnerability. It fuzzes by applying just kind of junk in certain parameters and then escaping them with a / and then reading the response whether something executed or an error came back or the content type was different. There's a whole bunch of checks that he does, but it's kind of like automated manual fuzzing. That's what I call it. And so it's pretty powerful, and it's a way to get back to kind of manual fuzzing for web vulnerabilities. And when Burp finds something that either returns a different content type, error or something like that, it gives you a scanner check in it, and it says suspicious input transformation. You should check this out, basically. So that's cool. These are all the resources for that section. Last section, how much time do I have? 5 minutes, cool. So the last section where we see bug hunters succeeding in finding big bugs is basically related to infrastructure and configuration vulnerabilities. This is one that we see a lot, which is subdomain takeovers. So this is the idea that you have a subdomain that at one time connected to something like one of these services, and then you let it lapse. And so you still have the subdomain mapped, and what happens is an attacker goes out and registers on one of these sites your subdomain. And since you let it lapse, they have the ability to register it. And then now they have control of one of your domains and inherit the trust of your users. So subdomain takeover, these are the ones that can be efficiently used. Basically, you don't have to provide credentials or IDs or company verification to register those things in most cases, or you can forge it. This was made by, well, it's basically coined or made popular by a tester named Franz Rosen. He has all these checks automated. I don't think anybody else really does. He's awesome. But it's pretty simple. You check to see if any CNAMEs are resolving to third-party services, and you make sure those things are either active, set up for renewal, and if they're not renewed, you nuke that CNAME basically. There's a whole bunch of tools for this. One written by Ben here called Hostile Sub Brute Forcer. Although is that maintained still or? Not you anymore. Okay, yeah. So he's the originator, but not the maintainer. TKO subs, auto sub takeover. There's probably like 6 or 7 tools that are looking for this now because it's an easy vuln, happens all the time, is usually a P1 on most platforms, so it gets you paid out at the top level. It's a big time bug. So misconfigured AWS. So this is S3 buckets. You read a lot about these. This is a whole probably day in itself, both hunting for S3 buckets that are associated to companies, and also taking them over, seeing if they're configured right. There's a couple tools in this section, one called Sandcastle, one called Bucket Finder. And there's some other ones that have recently just come out that I haven't used yet, so this presentation needs to be updated. But there's a whole walkthrough by Detectify and Franz, who wrote about basically taking over S3 sources, basically. So I'm not going to reinvent the wheel here. You can check that out. It's called a deep dive into AWS 3 access controls, taking full control over your assets. It's probably the best reference and most complete write-up I've seen on this type of thing before. The other one is Git. The idea that you have Git exposed off of your main domain somehow. There's a couple tools for this called GitRob and TruffleHog that will basically pull down source code repositories that are left open. The way you fuzz for this is in your directory brute forcing, you just add .git usually. And if you get a 200 OK on .git, it means they have misconfigured usually Git configuration, and you can try to download code that they've left out on the internet or through their repository. That's it. That's all I got. So some resources. The Bug Hunters methodology, the original one is on my GitHub, so jhaddix/tbhm. There's also a forum for bug hunters called the Bug Bounty Forum, and it's associated to a Slack channel, so like we all hang out in there and share techniques and kind of make fun of each other a lot, so you can check that out. And these are all the people that I pulled content from in the presentation. So you can check those out in the thing. And this is me, if you need to find me, at jhaddix or jhaddix@bugcrowd.com. That's it.